Hi, kids. Hey, welcome to Unit 2. Just quick review from Unit 1, where, remember, in Unit 1 we talked about Newton's first law, and then we also introduced Newton's second law. You guys are going to do a little online simulation to help finish up Newton's second law today, but this is just to just a real quick review. So, remember, Newton's first law essentially said this, if you add all the forces up on an object and you get 0, then that object is not going to accelerate. So what does that actually mean? If you remember, we started with, hey, in order for something to stay moving, what do you have to apply to it? What's the answer again? Oh, good, you said nothing. Very well. Very good job. You didn't say anything. I didn't hear anything. So, and you're right, the answer is nothing, because an object in motion stays in motion along a straight line at a constant speed unless acted on by a net outside force. So, if you add all the forces up and you get 0, then an object at rest stays at rest. If you add all the forces up and you get 0, then an object is going to keep moving in the same direction at a constant speed. Okay? So that was Newton's first law. Remember, it also related to inertia. Okay? Remember that inertia was the tendency for an object to keep its state of motion. Remember, inertia depends on mass. Remember, inertia is definitely not a force. Don't even say force of... I can't even say it because I just threw up a little bit in my mouth, but, force of and then this word, because that doesn't make sense. Okay, it's a horrible thing to say, so don't say that. Remember, we said, at least what we had so far was this. Okay, with Newton's second law, essentially we just said, hey, you know what? If you add all the forces up and you don't get 0, then your object will accelerate. Okay, so if you add all the forces up and you get a net force, well, that means you're going to accelerate. Okay, and remember, and this is important, the direction of the acceleration depends on the direction of the net force. We just finished Unit 1. We had projectile problems. What did your FPD look like for that? Oh, it looked like this. Okay. Which way did it accelerate? Oh, it accelerated straight down. Well, if the only force acting was gravity, then the acceleration was 9.8 meters per second squared down. Okay. If you remember when we did problems, and we're going to be reviewing, coming back to that, but if you have an object that's accelerating down a ramp, well, I have this force and I have this force. This was my normal force. This was the force of gravity. If I add those up as vectors, okay, hey, look, my result points down the incline. So what is that going to do? That means I'm going to accelerate down the incline. Okay, so remember, the direction of the net force tells you the direction of the acceleration, not the direction of the movement. Remember, you could be moving this way and accelerating that way. What do you do if you move to the right, accelerate to the right? Oh yeah, you speed up. Whereas you could be moving this way and accelerating that way. What are you doing if you're moving to the right and accelerating to the left? Oh yeah, you're slowing down, like friction. What happens if you're moving this way and you're accelerating this way? Oh, in that case, you're going to change direction. Speed up, slow down, change direction. What was an example like this? Hey, if you throw a ball horizontally and the instant you let it go, it's moving this way, it's accelerating this way. What is it doing? It's changing its direction. Beautiful. Okay. Bye, kids. Anyway, sorry. You are now going to look at and do a simulation that figures out really what is more the relationship between this force and this acceleration. Okay? All right. Bye, kids.